What does water behind a dam have in common with a full tank of methane? Well, as it turns out, quite a lot. Both have huge amounts of stored energy. With the dam, it's fairly intuitive why. All that water wants to flow downhill. But what about the methane? Let's follow the energy. This is Real Chem. The conservation of energy is key to understanding energy in chemistry. Here, I want us to focus on this directional flow of energy between a reaction and the surroundings. When we burn methane, energy flows out to the surroundings, helping us heat our house or cook food. But in some reactions, energy flows the opposite way. Let's explore. When any chemical reaction takes place, a change in energy occurs. Reactions that give off energy as heat to the surroundings are termed exothermic. Reactions that absorb energy as heat from the surroundings are termed endothermic. Because energy is conserved, the energy being released as heat must be coming from a change in the energy of the chemical system. For an exothermic reaction, the reactants have more internal energy than the products, with the excess energy being released as heat. It will raise the temperature of the surroundings, and if the surroundings are our hands will feel hot. For an endothermic reaction, the resulting products have more internal energy than the reactants. The energy needed to raise the internal energy comes from the heat in the environment, making our hands feel cold as they transfer the heat to the reacting chemicals. Chemical reactions cause the internal energy to change through the breaking and forming of chemical bonds. Breaking bonds always requires energy. For atoms to form a bond, they must be attracted to each other like two magnets sticking together. It will always take energy to pull these atoms apart, breaking the bond between them. Now, forming a bond is the opposite. It always releases energy. Different bonds have different strengths, and it is the balance of breaking and forming these different bonds that results in either a net gain or loss of energy. Now, if we break bonds and form strong ones, we have an exothermic reaction. We release more energy when forming the bonds in the products than we need to break the bonds in the reactants. There is a net decrease in internal energy, and the reaction gives off heat to the surroundings. In an endothermic reaction, we break strong bonds and form weak bonds. It takes more energy to break the strong bonds in the reactants than we get back from forming the weak bonds in the products. There is a net increase in the internal energy, and the reaction absorbs heat from the surroundings. To make a fuel like methane, we need a reaction that gives off energy or an exothermic reaction. To heat our house with methane, we burn methane by reacting it with oxygen to form water and carbon dioxide. For this reaction to give off heat, the bonds in the reactants, methane and oxygen, must be weaker than the bonds in the products of water and carbon dioxide. So, as it turns out, water at the top of a mountain and methane are both high energy systems. The water, because it is high up and wants to flow downhill, and the methane, because it has weak bonds that would rather rearrange to make strong bonds, which is precisely what we encourage to heat our homes. The key to both is establishing the direction of the energy. So explore and remember to have fun.